Remember, if I write things on the board, it's not to work on my biceps, triceps, and deltoids. I'm already dead sexy in my new August Christmas clothes. Right? So mineral classifications. This should be new to everybody, whether you've had the chemistry stuff or not. Mineral classifications. Science likes to classify things, right? We want to know if you're a dog or a cat, so we have different ways of classifying. We want to know if you're a plant or an animal. We want to know if it's living or dead. We want to know and classify. The best way to classify things in the mineral form is to go and look at their mineral composition. Or sorry, not their mineral composition. Look at their elements and the composition of it, their chemical formulas. So one of the most important chemical classification groups is something called the silicates. Take a random guess at what you think the silicates are made of. Silicone. The most important chemical or the most important element on Earth, the most abundant element on Earth in the Earth science world is
silicone.
Silicone. Do you know what the second most important abundant element is? Oxygen. Because silicates are not just silicone. They have some number of silicone atoms bonded to some number of oxygen atoms. So it's SiO2. It could be Si2O4. If you see silica bonded to oxygen next to each other, when you're looking at a chemical formula, you know that classifies itself or gets classified as a silicate. You could have a 20-string list of elements. So this mineral could be made up of 20 different elements. But if you see SiO2 bonded together in the middle of that string of 20, you're going to identify it as a silicate. Everybody understand the kind of classification we can go into with silicates? So silicates, 90% of rocks on Earth fall into the silicate variety. It is the most common rock out there. After silicates, you have rocks that are called oxides. Take a wild guess at what oxides have.
Oxygen.
Oxygen, right? So oxygen equals oxide. So anything that ends in an O, and I'm drawing a blank. Yeah. Corundum is an element, a metal bonded to oxygen. The last element, look at the last element. The last element is an oxide or an oxygen, so it falls into the oxide variety when we classify them. So they're classified based upon the elements that make them up. There are 7 major classification groups. So we have 2 of them. We have oxides and we have silicates. Next group. This one affects Indiana and is most likely found in Indiana. Carbonates. Ca, CO3. Carbonate. It ends in a CO3. Calcium carbonate. Calcium carbonate is found in one type of rock and one type of rock that I know of only, and that's limestone. Limestone is only formed in one way. Dead sea animals. The shells of dead sea animals get broken up and they get compacted together and they get turned into chalk and limestone. Does anybody know what the bedrock of the state of Indiana is? Limestone. So when you dig down underneath the dirt, you hit bedrock, it's limestone. Limestone only forms one way. Dead sea animals. So calcium carbonate is like those shells that you see on the backs when you're walking on the beach and you see the shells of like the sand dollars and you pick them up and you're like, hi mommy, look. And you see like the ones you put up to your ear. Yeah? No?
Yeah.
Those are dead sea animals, but if that would be at the bottom of the ocean, they get broken down into little pieces of dust. Those pieces of dust get compacted together to form limestone. So hold on one second. So if we dig down underneath our ground right here and it's limestone, what does that tell me about the geologic history of Indiana? At one point, I would be in water right now. If the bedrock of Indiana is limestone, right where I'm standing, I would be probably floating in the middle of an ocean or a sea of warm water. There would be water above me and water below me, because down below would be where the bedrock's at. You follow what I'm getting at? Sir, what was your question? The geological history of our place. Because the reason why I like rocks, and I'm weird because I like rocks, I get it, is because it's not about the rock. If you know how the rock forms, then you can picture what the history was like. So you see these pictures of what dinosaurs were walking around, and they draw these pictures of these big plants. How do they know that these plants existed? Most of that information is coming from the rocks. Because I can tell you, based upon the rock type that you have in that location, what the geologic history of your region was like, and that tells me, based upon what the geological regions of these are, tells me what it looked like back then. The history of the location, you can tell from the rock. Yo.
So you said Indiana is one of the biggest for limestone?
It's not. It is one of the nation's biggest. The Empire State Building, the Pentagon. Because they just, when the World Trade Center got hit, the Pentagon also had a plane run into it as well. When they went to rebuild the Pentagon, they actually had to reopen a quarry because the quarry was closed down in southern Indiana because it was made from that specific kind of limestone. So they reopened the quarry to use that limestone again. So it was dead, it was not used for 10, 15 years. They reopened it to cut more blocks to rebuild the Pentagon. And it came from southern Indiana. So we are one of the biggest in the United States. Italy is huge with like marble and limestone, and there's a couple other regions that are pretty big, but Indiana is a very big, there's rock quarries all over the place.
What I meant is, like, does that just mean that Indiana was one of those, like, the underwater, or the section region of Indiana is underwater?
Wherever you find that limestone, so if you can follow and you can trace where that bedrock starts and stops, that is evidence of it being it's evidence of it being underwater. So I'm not sure exactly where the outline of it goes. I mean, it's a bigger region, and I believe it's much of the Midwest, and we got lifted up. So you have carbonates. The main point of that is you have carbonate, right? Carbonate ends in CO3. If it ends in CO3, it belongs to the carbonate group. So you have silicates, you have oxides, you have carbonates. The next category of classification is native elements. Native elements are made up of one and only one mineral. Their entire chemical composition is one mineral. It's the native element. Two that I couldn't remember. What mineral is C? So what element is C? Carbon. What mineral is made entirely of carbon? I mentioned earlier today. Diamond. Diamond is one mineral. There's another mineral that is made entirely of carbon. Graphite. Funny thing to say that graphite and carbon are exactly the same chemical composition. Do they look the same? Do they feel the same? No, we'll figure that out when we start looking at them, but they're all made with the same element. Another example of a native element is copper. So copper is an element, but it's made up of all the copper ion or copper elements. You have a halide. That one you may not know, because it's off from the periodic table. Does anybody know where the halide column is in the periodic table? Nope, it's column 7. So take a guess at what's one of the most common halide minerals. Salt. Does mineral match my definition for a mineral? Sorry, does salt match my definition for a mineral? Is salt naturally occurring? Can I walk outside and hit a rock and get some salt?
Yes.
Is it inorganic? Is it a living thing? Is salt inorganic? It's non-living. Is it a solid?
Yes.
Does it have a chemical composition?
Yes.
NaCl. Does that chemical composition have a structure? Yes. Salt is a mineral. Salt belongs to the halide group. You have a sulfur group. No, sulfide. It's called the sulfide group, but they end in sulfur. If I gave FeS2 to David, he'd be happy. He thought he's rich. Because FeS2 is commonly referred to as fool's gold.
I actually have some of that.
Right? FeS2 is commonly referred to as fool's gold.
Pyrite.
It's pyrite's the actual name of the mineral, but it's fool's gold because it has a gold color and it's not really. Oh, you had a question. So it's fool's gold. So if I gave it to David, he'd be happy. Finally, we have the sulfate. And sulfate ends in SO4. The most common sulfate is also an evaporite that found in Indiana, and it has to do with building materials. The most common sulfate goes into sheetrock, and it's gypsum. Gypsum. It's from a rock. So the board, the drywall, it's made from a mineral called gypsum. Gypsum. So if you go into your M2, go ahead and cut it off.